Okay, we're going to be looking at the remainder theorem. And what the remainder theorem states is that if I have some polynomial p of x, which this is kind of like f of x, but p, because it's a specific function, it's a polynomial. So if I have a polynomial and I divide it by x minus a, then the remainder is p of a. Or in other words, I can evaluate that function at the point a. So here's an example. If I have a polynomial, x cubed minus 5x minus 3, and I divide it by x minus 2, here's my general form for that polynomial, I know that this remainder right here of negative 5 is the same value as p of 2. And down here I have evaluated the function value at 2, and you can see that this remainder here of negative 5 is the same as p of 2 here with negative 5. Okay, so let's look at a couple of examples. Over here on the left, the problem says to use the remainder theorem to find f of 3. So here I have my function value, and what this is saying that I can divide this polynomial, and whatever my remainder is going to be the same value as f of 3. So I can put 3 in this box, and I have 2, 7, 0, negative 5 for my coefficients. Bring down this 2, 6, 13, 39. 39 times 3 is 117, and that's going to give me 112 for my final answer. So this is saying f of 3 equals 112. Over here, this says to use the remainder theorem to find the remainder. So what I want to do here is find f of 3 by just plugging 3 into my polynomial. So I have 2 times 3 cubed plus 7 times 3 squared minus 5, and that answer is 112. So either way, I get the same answer here of 112, right? Because f of 3 is my remainder. And I think that our textbook sort of, or at least my math lab, sort of misses the mark on really getting to this part right here by not doing these problems right here. All of your homework in my math lab is going to have the directions that's over here on the left. I think you really need to understand both of these to really understand the importance here. On the problem here on the right is saying that I'm interested in the remainder. I really don't care what the quotient is. If I go back up here to my first example, I don't really need to know this part over here, the x squared plus 2x minus 1. I don't really need to know that quotient. I just want to know the remainder. So instead of going through this process of synthetic division or long division, I can just evaluate that function at 3. Okay, let's look at an example like you're going to see in my math lab. The directions say find f of negative 1 using the remainder theorem, and here I'm given my function. So I want to find f of negative 1. That negative 1 goes in my little box here. My coefficients are 5, negative 3, and 8. So I can use synthetic division. I can see that my remainder is 16. So f of negative 1 equals 16. Okay, on my next example, I want to find f of 2 plus 3i using the remainder theorem. So 2 plus 3i is my divisor. It's going to go over here in my box. And my coefficients are 1, -2, and 4. And when I write them down, I'm going to spread them out because I know that I'm dealing with this complex number up here, and I'm going to be needing a little more room. Okay, so this first part is fairly easy. 1 times 2 plus 3i is just 2 plus 3i. And when I add those, the 2 and -2 cancel out. So that leaves me with 3i. Now I need to multiply 3i times 2 plus 3i. And remember that when you put that in the calculator, you're going to need to put the 2 plus 3i in parentheses. First of all, be sure your calculator is in the correct mode to be accepting numbers of a plus 3i form. When you multiply that, you get -9 plus 6i, and add, you have -5 plus 6i for your final answer. So f of 2 plus 3i equals -5 plus 6i. All right, my next example, I'm trying to find f minus 2i using the remainder theorem. So f minus 2i goes in my box. My coefficients are 1, 6, and -7. Bring down this 1. 1 times 5 minus 2i is 5 minus 2i, and that's going to give me 11 minus 2i when I add them together. Now, when I get ready to multiply the 11 minus 2i times the 5 minus 2i, and I put it in my calculator, I have to be sure that I put both of those terms in parentheses, just like this. They both need to be in parentheses, and when you multiply that, you get 51 minus 32i. So your answer here is 44 minus 32i. So this remainder is equal to the function value at f minus 2i.